Hi there, this is Mar Haddad here again. In this new video that I'm posting on my YouTube channel, I'm going to show you how you can configure your MikroTik router to become a wireless access point router. So that means that in case, for example, you just bought a MikroTik router and you want to put it at your home to provide for you internet wirelessly to your home, then this video will show you step by step how you can do that. And we are going to make this configuration on the latest RouterOS version 7. So all the configuration will be done on the version 7. As you can see here, we have a lab of 7 pawns. Before I start doing those pawns, I would like to go first to the lab scenario to show you what is our scenario, and then I will come back to the pawns and start doing them. So this is our lab scenario. As you can see here, I have the internet, which is coming from my ISP, and I'm going to connect it to a cable to my Ethernet 1 on my MikroTik router. So the ISP over here, they have a Dhcp server. That means I need to make the Ethernet 1 as a Dhcp client to be able to receive the IP address, the subnet mask, the gateway, and the DNS from the ISP Dhcp server. Then when I do that, then this router will have internet. Very good. So this router will have internet. Now what I need to do is I want to provide internet from this router to my home. So anyone who is plugging his computer to any of the ports which are Ethernet 2, Ethernet 3, Ethernet 4, Ethernet 5, then he can also connect to the internet. But also I want to do the internet to be propagated on the wireless. So anyone, for example, who has a phone and he's connected to the wireless of the router, then he can also have internet. So that means we have to configure, in this case, the LAN side. So we have to configure the DHCP server on the router 1. We have to configure NAT, and we have to configure the wireless. And of course, we have to configure the bridge to put all those ports inside this bridge. So anyone who connects to any of those ports by a cable, then he has internet. So all of those things we are going to cover in this lab. Don't worry, we are going to go step by step, point by point, and then you will understand at the end how you can set up your MikroTik router to become a wireless access point router. So let's go now back to the points and start doing that. Point number 1, go to Winbox, IP, then the DHCP client, and select the interface Ethernet 1 to get IP from the ISP DHCP server. Very good. So as I have already explained, my ISP is giving me the internet or the IP on the DHCP server. So we have to enable the DHCP client on the router on the interface Ethernet 1. I put the picture so you can follow what I'm doing with the picture on top of the screen. So now I have to go to IP. I have to go to the DHCP client. Before I do this configuration, look, the version is 7.3.1, which is the latest version as for today. So I'm working on the version 7 on the MikroTik router. So over here, we have to go to the DHCP client, and then I make plus, and then I will say I want to enable the DHCP client on the interface Ethernet 1. I want to receive the DNS. I want to receive the NTP, which is for the timing, so my router can get the time synchronized with the NTP server of my ISP, so the clock will be synchronized. And I want to receive a default route. Before I do that, let me show you. If I put here IP address, I don't have any IP address. If I put here also IP routes, I don't have any route. All right. And if I also go to IP DNS, I don't have any DNS. So I just put all those in front of you so you can see what's going to happen. So now I just enable that. Okay. Look, it's searching. He got the IP. So look, he got an IP. That's the IP with the subnet mask. He got the gateway, which is over here on the route. And he got the DNS, which is on dynamic servers. So very good. So that means my router at this time, if I try to go to the command prompt and I try to ping to google.com, we shall see that my router is able to go to google.com. So when you ping google.com, that means you check if the internet is working, but also you check if your DNS is working, and both they are working. Very good. So my router now has internet. We have to see now the steps how we can share the internet from that router to my inside LAN on anyone connected to any of my ports of my routers. He can get internet, but also on the wireless, because we want this router to become a wireless access point router. Point number 1 is done. Point number 2, ping from your router to 8.8.8.8, then google.com. Do you have a reply? We have already tried that, and yes, we do have a reply. So this point is done. Port number 3. Now we have to create a bridge interface and not internet. So this should be a bridge interface, and put all interfaces inside of it except Ethernet 1 on that bridge. So what does it mean here? If I go back to the picture, so at this moment, what I have is that this router is connected to the internet. Very good. Now, what I want also, because this router has 5 ports, Ethernet 1, 2, until Ethernet 5. So I want anyone who put his cable on Ethernet 2, 3, 4, and 5, he can also go to the internet. So what I can do, I can just bridge all those ports. I put them inside a virtual interface, which is called, we can call it bridge, we can call it LAN, we can call it whatever we want. But that's a virtual interface where we bridge all those ports together. So they become like switching ports. And then wherever you plug your cable, then it's gonna work the internet. So let me show you how we can do that. First, let's check what ports or what interfaces we have on the router. If we go to interfaces, we can see that I have Ethernet 1, which is my WAN. I don't want it. Then we have Ethernet 2, 3. So I think that I'm connected to Ethernet 3 now by cable because I have an R means running. And then Ethernet 4, Ethernet 5, and I have WLAN 1 and WLAN 2. Those are the wireless. WLAN 1 is for the 2.4 gigahertz. You can check that over here. This is for the 2.4 gigahertz. And WLAN 2 is for the 5 gigahertz. So for this lab, I'm going to use only the 2.4 gigahertz. You can also use the 5 gigahertz if you want. That's not a problem. So I'm going to enable also that one. Now I want to put Ethernet 2, 3, 4, 5, and WLAN 1 inside a bridge interface. And then on that bridge interface, I can configure the DHCP server. So anyone connected to any of those ports, which are 2, 3, 4, 5, and WLAN, he will get an IP address from the DHCP server that is configured on the bridge. You got my idea? Very good. So let me show you how we can do that. So we go to bridge. We create a bridge interface, and let's name it LAN, so we can refer to it as being the LAN site. So this is the LAN, it's a type of bridge. And now I want to bridge all those ports together. So I'm gonna say Ethernet 2 inside this bridge. And then I'll make copy Ethernet 3 inside this bridge. Now we may get disconnected. Ethernet, yeah, here we go. So we got disconnected, but we will get connected in a moment because we moved the Ethernet 3 from being a physical port. We just put it inside the bridge. No problem. Now we make copy Ethernet 4. We put it inside that bridge. Copy Ethernet 5 inside this bridge. Copy and the wireless, which is WLAN 1. So now if we look what we have put all those ports inside the bridge interface. Very, very good. So now what I need to do is to just put an IP on that bridge and configure the DHCP server on that bridge, and we do the NAT. Then we have the internet working on any of those ports. Just to mention something, that you will see over here an H on the wired port or the physical port, but not on the WLAN. H means hardware offload, so this is the one. What does it mean? That means that in case anyone speaking from, like you have two computers, one connect to Ethernet 2, one connect to Ethernet 3. So they are sending to each other traffic. Then the traffic will not go to the CPU because it will go inside the switch chip, which is inside the router. Then the traffic will go directly from the PC to the switch chip to the other PC without passing to the CPU to not take too much load on the resources of the routers, which are the CPU and the memory. So when you have those wired ports, so you have the H. The WLAN, because that's another technology, that's a wireless technology, then you don't see the H, even though that is checked here, but this one cannot be hardware offloaded because that's another technology, but you can still bridge it with the other ports. So that means in case someone is trying to speak from the wireless side to a computer which is on the LAN on Ethernet 5, then the traffic has to go to the CPU. Now, forget about that. That's not important for our lab, but just I wanted to explain this to you. Now, very good. We have done that. So let's see what is the next step. Point number 3 is done. Point number 4, put an IP address on the bridge of 192.168.1 and configure the DHCP server. So if I go back to the explanation here, So what we need now to do over here on this bridge interface, we have to put an IP. Why we need to put an IP? Because on that IP, I want to create a DHCP server. So if you don't have an IP on a bridge, then you cannot configure the DHCP server. Why I need to configure the DHCP server on the bridge? Because anyone who's connected to any of those ports that I have put them inside this bridge, then he should get an IP. And of course, the subnet mask, a gateway, and the DNS. So all those information needs to get to be able to go to the internet. So I'm going to put an IP on the bridge 192.168.1, and then I'm going to show you how you can configure the DHCP server. Let's do that. So this is what they're asking us. So let's go to the router, and then now I will go to IP address. I will put an IP on the bridge. It's gonna be 192.168.88.1. You can put any private IP address. It doesn't need to be 88.1. It can be anything, but should be from the range of the private IPs. And I put it on the bridge, which I call it LAN. So now we see that there is an IP on the LAN side. Very good. Now I'll configure the LAN to be a DHCP server. So DHCP setup, and this needs to be done on the LAN, which is the bridge. So here you have just to say next, next. Look, they say, okay, I discovered that this is the address space 88.0. Yeah, that's correct. Next. And they said, this is going to be the gateway, because all the traffic of the LAN users will have to send to the gateway, which is the IP of the bridge interface. If you look, this is the IP we put it on the bridge interface, .88.1. So this is going to be the gateway for all users, which is correct. Next. And it's going to give IPs from 192.168.88.2 until 88.254. You can adjust that if you want. You can start it, for example, from 10 to 254 in case you have some servers that you want to give them some static IPs. But in my case, I'm going to leave it like this. The DNS, you can choose the DNS you want. I'm going to leave the DNS as it is by default. Next, and the least time is for 10 minutes. That means every 10 minutes, the connected computer or device will have to request for DHCP again. You can make it bigger, you can make it smaller if you want. I will leave it as it is by default. And then next. So that's it. That's what you need to do. Now, if you look to the picture, my computer is connected to the router on Ethernet 2, they said on the picture, but actually it is connected to Ethernet 3. But anyway, it doesn't matter. Ethernet 2, Ethernet 3, Ethernet 4, Ethernet 5, all are on the bridge. But let's check if my computer has received an IP. Let's have a look. So I will open here the command prompt from my computer. If I say ipconfig, look, you see, he received directly 192.168.88.254. So he has received the IP from the bridge. Very good. So now if I ping to 192.168.88.1, which is his gateway, here we go. He has a ping reply. Excellent. But does it mean that he can go to the internet? Not yet, because there is still one missing thing that we have to do. Point number 4 is done. Point number 5, configure NAT on the router. So what does it mean here? This means that at this moment, the computer cannot go to the internet. Actually, let me just show you. If I go back to the command prompt and I open it, and then again I do ping to 192.168.88.1, we see that we have a reply. But if I try to ping to 8888, which is the Google DNS, you see it's not able to go to the internet. So it's reaching to the router, the traffic, but not able to go to the internet. And there is a reason why. So let me explain to you what is the reason. Let's go back to the picture and let me explain. So what's going to happen? Remember that on the router over here, these are private IP addresses. Private IP address cannot be routed to the internet. So it can't go to the internet. Then when it comes to the router 1, he say, oh, you are private, you can't go to the internet. So what we need to do, we have to make on the router what we call network address translation. To translate those private IP addresses to public IP addresses so they can go to the internet. That's what the NAT is. Now, someone can say, but hey, on Ethernet 1, so if we go back to the router, on Ethernet 1, which is the WAN side, we have also a private IP address. You see it, 192.168.23.250. That's also a private IP address. So you said you want to translate from private to public, but over there is also a private IP address. So how come? Yeah, that's correct. We still need to do the NAT because we need to NAT those addresses to the IP which is on the Ethernet one. Yeah, but also this one, Ethernet 1, cannot go to the internet by itself, because what happens is that on the ISP router there is a router here also, and they're making NAT, and over here they are translating the IP which is on Ethernet 1 to the public to go to the internet. So we have in this case double NAT. Yeah, but yeah, let's not think about that. Just remember, every time you have a private IP address, the private to go to the internet, you need to make the NAT to be able to translate the private to the public IP. But over here, the last NAT is happening on the ISP router. So over here, there is a public IP on the WAN interface over here, and the NAT is happening on the also ISP router, so it can go to the internet. So let me show you how you can do the NAT. So we have to go to IP Firewall. And then we go to the NAT, and I will create source NAT. Any traffic going out on the interface Ethernet 1, you can specify if you want. Here you can put 192.168.88.0/24. So any traffic coming from this network going out of interface Ethernet 1, you can specify that, and also if you want, you cannot specify it. It depends on how you want to do it. I will just leave it. All right. So any traffic coming from this range of IP going out of interface Ethernet 1, then the action is to masquerade. Masquerade means to NAT, and then apply. So now, if I go back to the computer here where we were trying to ping, and we have request timeout. Now we try to ping on 88. Here we go. It is working. If we ping also google.com, yeah, it is working. So my computer at this moment is fully connected to the internet. Point number 5 is done. Go to your PC and ping to 8888. Does it work? Also, we tried and it is working. Now, before we go to point number 7 to configure the wireless on the router, and then we connect our phone to the wireless. What I want to test is that I will open a ping here, and remember, my computer is connected to the interface Ethernet 3 on the router. So I'm going to come on the router and I have to unplug. So let me just keep the ping extended. So now the cable, you see, this is the cable of my PC. I took it out. So we don't have internet anymore. Yeah, Winbox has closed. That's fine. All right, I'll put it on Ethernet 2 now, just to see if we will have also internet if we put it on Ethernet 2. So it's now plugged on Ethernet 2. Let's wait to see. And that's what to check if the bridge is working or not. So it is connected to Ethernet 2. Let's have, wait a bit. Here we go. It's working again. I will remove the cable. So I removed it, put it on Ethernet 4. So that's a test to see if the bridge is working. Because remember, we put all the ports on the same bridge. So I just plug it on Ethernet 4. It has to request now for the IP and from the Dhcp server, and it's working again. I will move it and put it on Ethernet 5. So this has been connected to Ethernet 5 now. And here we go. Very good. So I will leave it now on Ethernet 5 to be able to access to the MikroTik router. Now, the next question they're asking us here is that configure wireless on the router and connect your phone to the wireless. Does the internet work? So now on the ports, everything is fine. So let me just clean it a bit. All right. So on the physical ports, everything is working without any problem. Now what I want, and that's the main reason why I decided to do this lab, is that I want also that this router provide me internet on the wireless. And I'm going to have my phone over here, and I want to connect to the wireless to see if I can go to the internet. Now remember, if we go back to the Winbox, let's connect again. So on Winbox, we said that on the bridge, we put also the wireless, but we need to configure the wireless actually. So we have to say, what is the SSID? And we have to put the password. So let's do that. Now, On the wireless, all you need to do, if you don't have any experience on the wireless, you just have to come over here and you can say AP bridge. AP bridge means access point bridge. But then the SSID will be a MikroTik. It's gonna be propagating on the 2412 megahertz frequency, and it's gonna use the BNG. Here what you can do, you can just tune that configuration. So I'm not gonna apply that now. First I need to create a security profile. So anyone who has the password, then he can connect to that wireless. So I will create a security profile, dynamic keys. Always choose WPA2 PSK, which is the more secure one, and AES. So let's put the password for this is a lab. I'm gonna use 1, 2, 3, 4, 5, 6. But if you are doing this on a real network, don't use this simple password. I think we have to make it a bit bigger. 789. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the password of the wireless. Now I will go to the Wi-Fi. Say that now the first thing that I want to check is that I want to see which frequency to use, which is not used too much in my environment. So what you can do, you can just use the frequency usage over here. And then you start the frequency usage. You can see which of the frequencies here is less used. So we can see that 2422 is maybe the best frequency to use. So stop. I will go over here and I'll say I want to use 2422. That's it. I'll put again AP bridge. I'm gonna use the N actually, because that's the fastest technology on the 2.4 gigahertz. And then I'm gonna put here the SSID. That is the name of the wireless. When someone is trying to connect to the wireless, you see the name of the wireless. So I will just make it test lab. Alright, so we can see that on the phone when we do that in a moment. And then the last thing is just I want to put the security profile that I have created with a password from 1 to 9. And then that's it. So now, believe it or not, the wireless is working. Let's try. I will take my phone now and let's see if I can connect to this wireless. So I will show you here on my phone. Let's put it here so we can see. Here we go. We see the test lab is showing up. Then I will click on it. Let's ask for the password. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the password, and then I connect. And let's wait a bit to see if we are going to be connected. Checking the quality of the internet and connected. Excellent. And if we go to the MikroTik router on the wireless, we can see that inside the registration. So we are connected, and it is my phone. Very good. Now, if you want to make a test to see if the internet is working on the phone, I have here an application. Let me just put the phone back to you and see if it's gonna ping to Google, for example. Let me put it back. Here we go. So ping to google.com. Here we go. So my phone is connected to the internet. Very good. So by doing those steps, we have completely done the lab, which is how to make the MikroTik router as a wireless access point router. Point number 7 is done. And with this point, I have finished the whole lab, showing you how you can configure the MikroTik router based on the RouterOS version 7 to make it as a wireless access point router. If you like my way of teaching, please do not forget to put like on this video, and please do not forget to make subscribe on my channel so you can see more videos when I upload them on my YouTube channel. Thank you very much for your time, and see you next time.